So let's see what this IPsec is. IPsec stands for IP security, and it encrypts data at layer 3, meaning the IP layer. And then we have underneath IPsec we have 4 sub-protocols, because IPsec uses these sub-protocols to perform its task. We will in the next slide see a graphical illustration of how this works, but first we will go through them. So the first protocol we have is ESP, Encapsulation Security Payload. This is the protocol that encrypts the content, meaning the data that we have, with a symmetric algorithm. This means that both the client and the server will have the same algorithm, such that what is used to encrypt the data can also be used to decrypt the data. Because you cannot just encrypt it on your side and then just hope that the server somehow managed to figure out whatever you encrypted it with. There need to be a correlation between them, and you need to exchange some information for this to work. But ESP is the encryption part. Then we have HA, authentication header. This is a header that is added on to our data package, which have a checksum in it in order for our server or ourselves, when receiving packages again, to check up and secure that no one have tampered with this data. Because if they have, then the checksum and the hash of this authentication header will simply not match, and we know that someone has been trying to manipulate this data, and we either know that our encryption, our private network, has been broken, or something has gone wrong through the way from our point A to point B. Then we have the IP comp, which is the IP payload compression. This is where our payload, meaning our data and our authentication header, is getting compressed such that it is of a smaller size before we send it, because the less data size that we have, the faster it is and the less bandwidth we use. So it is very important that we can compress it as much as possible before we actually send it. And then we have the last protocol, which is the IKE, Internet Key Exchange, and that is the protocol that negotiates the shared secret between us and the receiver. So as I said, in the ESP, the Encapsulating Security Payload, we need to negotiate some shared secret in order for us to be able to encrypt it in one end and for the receiver to decrypt it in the other. So we need to have some common knowledge in order for this to work. So this is basically the 4 sub-protocols that IPsec uses. So let's see how this works. So the first thing that we have is the part 1. We need to negotiate a shared secret or key before we can start doing this, such that we have an understanding of what it is used to encrypt and what is needed to decrypt. Once that is in place, we can encrypt the data with ESP. So for example, we have a package right here with the black square. We have data, then we will encrypt it with this green layer right here. So now this entire data block is encrypted. In the next part we will add this authentication header, so we will add it to the data package, which is encrypted. And at step 4 we will add a new encrypted layer around this entire package, so around the header and around the data, because then the header is encrypted as well, and then there will be a minor header to this encrypted package with the receiver's information, because we need to detail where this is to be sent to. So this is when we are encrypting our data in one end, and then the receiver is getting the package. The first thing that he is going to do is remove the outer encryption layer, so he will remove this blue box right here. Then he will check the header, see if everything is in order, has the data been tampered with, and then it will be removed, so we will take out the header. And then at last he will decrypt the data, so he will encrypt this green box right here and remove it, and then he is capable of reading the exact same data that we started off by sending right here. So this is basically how VPN protocols and the different sub-protocols is used to do this entire virtual private network over a public network. But we need one more protocol, and that is the ISAKMP protocol, so the Internet Security Association and Key Management Protocol. It's a very long name, and if you're really into this VPN stuff and you need to go beyond the basic, which this is all about, then I highly recommend you to do some reading of the details of these different protocols, because there's a lot of more into them than just what I have listed right here, but this is the basics. So this protocol is actually used to establish the tunnel, and that is what do the start exchange of keys and provide the tools needed for us to have this tunnel before we can start to use the L2GP protocol and the IPsec on top of that. So this is basically how VPN from client to server over a public network works, and how it is getting encrypted using several sub protocols.